let's do number 10. We have a 3 centimeter tall object is placed along the principal axis of a convex lens. Now that's another word for a converging lens that looks like this. If you have a diverging lens that's like this, it's actually called a concave lens. So I don't usually use the words convex lens and concave lens because then it gets confusing with the mirrors. I just would call this a converging lens and this one a diverging lens. But it is a positive focal length because we are talking about a converging lens. So let's see what we're given here. We are given the height of the object. We are given the focal length. We are given P, the object distance. And we want to know Q and H prime. So to find Q, we're going to use the thin lens equation. Just like in the previous problem, it's going to end up being PF over P minus F. This was derived in problem number 6 from the thin lens equation. So we're going to put in the P and the F that are right here, the 40 and the 30, and we're going to get 120. And then to get the image height, we need to use the magnification equation. That's going to give us the magnification first, or if you want to directly say, well, the magnification is image height over object height, then you can use this to find the image height directly, negative H times Q over P. And you plug in the 3 and the 120 and the 40, and we will get 9 centimeters for the height. So it seems like actually that it'll be a negative, which means that it's going to be inverted, but none of these choices had a negative. But we can double check by drawing a quick sketch here. If we have our converging lens, and the focal, let's say this is 30, so 1, 2, 3, 4. So the focal length is right here, and the object is right here. Then let's see what happens. So the focal length 1, 2, 3. The focal point is right here. So we're going to go parallel and through the focal on this side. I'm just doing a rough sketch here. We're going to go through the center. You can see they're going to intersect somewhere over here. And if we go through the focal on this side, and then we come out parallel. Again, it's a rough sketch, but we can see that the image does end up being inverted. So it is negative, but none of these choices had a negative, so this was the best answer. Number 11, we'll just do this one with the equations. So the magnification is 1/5, it's M, and 20 centimeters is the object, that's P. So we're looking for the focal length, so we know that to find F we need Q, and to find Q we need to use the magnification, so we use M equals negative Q over P. And that will give us Q equals negative P times M, which will be negative 4. And then we use a thin lens equation, and we solve for F, which we have done in a different problem. We get P over Q, P times Q divided by P plus Q, when we use a thin lens equation. And this was done in problem number 7. So we just plug in the P's and the Q's in here, pay attention to the negatives, and we'll get negative 5 for the focal length.